Hello everyone. Um, for today, let's solve another problem about arithmetic series. And our problem is find the sum of the given series 11 plus 15 plus 19 up to 87. So the first thing we should do in solving problems like this, or problem like this, is to identify first the given. So let's write here given. And obviously from the given sequence, it's quite obvious that 11 is our a sub 1, and then our a sub n, which is the last term, is 87. And from the given sequence, we can actually find the common difference outright. Recall that the common difference is simply the difference between the next term minus the previous term. Or in this case, we have a sub 2 minus a sub 1. So our a sub 2 here is 15 here, and a sub 1 is equal to 11. And 15 minus 11 is equal to 4. Or we can actually verify whether we have the right common difference by using a sub 3 minus a sub 2. So we have a sub 3 minus a sub 2, that is equal to 19 minus 15, and still that is equal to 4. So let's write our common difference is equal to 4. And from the given sequence, we all know that 87 is the last term, a sub n, but we don't know yet what number or what term in the sequence the number 87 is. So that simply means that n here is unknown, and that's what we are going to solve first before we can solve actually the sum of the given series. But before solving this one, let's recall first the formula for finding arithmetic series. And the first one here is we have s sub n is equal to n over 2 times a sub 1 plus a sub n. So to solve for the sum of the terms in an arithmetic sequence, we need to have a sub 1. So we have a sub 1 here and a sub n, which is 87. However, notice that we don't have the value for n. That is why I've said earlier that we need to solve first for n. And our second formula is given by s sub n is equal to n over 2 times the quantity 2 a sub 1 plus quantity n minus 1 times d. So using this formula, we should identify first, or the common difference should be given here. The value of n should be given as well, and a sub 1. But as I've said earlier, n is unknown here. Hence, whether we use the first formula here or the second formula, we need to have the value for n first. That is why we have to solve for n. And to solve for n, we're going to use the arithmetic sequence formula, given by a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Okay, we can actually substitute directly all the given to this formula, or we can derive the formula first for n using this arithmetic sequence formula, and let me show you that. So we're going to solve for n here. So a sub n is equal to a sub 1 plus I'm sorry. So to solve for n here, let's transpose a sub 1 to the left. So we have a sub n minus a sub 1 is equal to the quantity n minus 1 times d, and divide both sides by d. So we can cancel out d here, and we have a sub n minus a sub 1 all over d is equal to n minus 1. So all we need is n. So we need to transpose negative 1 to the left. So we have a sub n minus a sub 1 all over d, and transposing negative 1 to the left, that becomes positive 1 equals n. Therefore, we have a sub n minus a sub 1 all over d plus 1 equals n. So we can use this formula to find the value of n instead of substituting the values directly to the arithmetic sequence formula here. Okay, so let me show you on how to solve the value of n by substituting all the values directly to the arithmetic sequence formula. So let's have here solution number 1. Let's denote this one as solution number 1. So a sub n is equal to a sub 1 plus the quantity n minus 1 times d. And 87 is our last term, a sub n. Our a sub 1 is 11 plus n minus 1, since n is a known, and d, which is 4, as our common difference. And let's simplify this. We have 87 equals 11 plus, so we need to simplify this by distributing 4 inside the parentheses. So 4 times n, we have 4n, and 4 times negative 1, we have negative 4. And let's simplify further. So we have 87 equals, we can combine 11 and negative 4 outright. So 11 minus 4 is 7 plus 4n. And we need to transpose 7 to the left. So we'll have negative 7 plus 87 is equal to 4n. And negative 7 plus 87 is equal to 80 equals 4n. And to solve for n, we need to divide both sides by 4. So cancel out 4. And 80 divided by 4 is equal to 20. Therefore, the value of our n is equal to 20. That means from 11 to 87, there are 20 terms. or there are 20 terms in the sequence. Okay, so we have now the value for n. And we can solve now for the sum of the given series from 11 to 87. So we can use the first formula here or this one. But for this problem, I think the best formula to use is number 1. So we don't need to complicate things. So let's solve the sum of the first 20 terms in the given series. So S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. So we have now S sub 20, since the value of n is equal to 20, and 20 over 2 times our a sub 1 is 11 plus a sub n is equal to 87. Then observe that we can simplify 20 over 2 outright. So 20 divided by 2 is equal to 10 times 11 plus 87 is equal to 98, and 10 times 98 is equal to 980. Therefore, the sum of the first 20 terms in the sequence is 980, and that is our final answer. Okay, earlier I've derived the formula for n here instead of substituting the values to the arithmetic sequence formula. Now let's try to solve using this formula if we will arrive at the same answer. So we have n is equal to a sub n minus a sub 1 all over d plus 1. And a sub n is equal to 87 minus 11 over d, which is equal to 4, and then plus 1. And 87 minus 11 is equal to, what's that? 66. Am I right? 76. So we have 76 over 4 plus 1. And 76 over 4 is equal to 19 plus 1. Therefore, n is equal to 20. As you can see, we've got the same value for n. Okay, so it doesn't matter if you use the formula, arithmetic sequence formula, and substitute the value outright, or this one. That depends on you, which formula you are comfortable using in solving problems like this. Okay, so that's all. If you have any questions regarding the solutions we have, try to comment down below in the comment section.